Today, we're going to unlock a story that's been buried for hundreds of millions of years. It's the story of Earth's carbon vault, this ancient store of energy that was locked away for eons. So, what happens when humanity finds the key and unleashes all that history in what's basically a geological blink of an eye? This one question really gets to the very heart of our modern world. Think about it. We've created this radical imbalance, right? We've got millions of years of slow geological storage on one side versus just a few seconds of combustion on the other. And understanding that mismatch, that difference in speed, is the key to understanding our planet's current situation. So, to really get how we open this vault, we first need to look at what was even inside it. The best way to think about fossil fuels is like Earth's ancient savings account, one that was really never meant to be spent all at once. Okay, so for hundreds of millions of years, you had countless plants and tiny organisms capturing the sun's energy. Now, when they died, that energy didn't just disappear. Nope, it got buried, compressed, and slowly transformed into the coal, oil, and natural gas we use today. So it's literally ancient sunlight locked deep inside the Earth's crust. And here's the really crucial part to understand. All of this carbon was taken out of the active everyday carbon cycle. It was put away, sequestered, stored safely in this geological vault. It was part of a very slow, balanced system that helped keep our climate stable for millennia. All right, so now let's talk about how that ancient balance got completely turned on its head. For almost all of human history, that vault stayed locked. But then, we found the key. And right here, you can see the fundamental difference. Look on the left, nature's way of releasing this carbon is incredibly slow and gradual. It happens over geological time through things like rocks weathering or volcanoes. But now look at the right. Our method is instant and massive. We found a way to completely bypass nature's speed limit, unleashing all of that stored carbon pretty much all at once. And it all boils down to this incredibly simple chemical reaction: combustion. You take carbon, you burn it with oxygen, and you release a massive amount of energy. That simple formula you see on the screen, it built our entire modern world. It also became the trigger for emptying that geological vault in the blink of an eye. So, what happens when all of this ancient extra carbon suddenly floods into the atmosphere? Well, it takes a natural process, the greenhouse effect, and it cranks it up to 11. It's like we're thickening the planet's atmospheric blanket. The process itself is pretty simple. Sunlight comes in and warms the Earth. Some of that heat then radiates back toward space. Now, greenhouse gases, like CO2, act like a blanket, and they trap some of that outgoing heat to keep our planet livable. The problem is, by pumping out trillions of tons of extra CO2, we're turning that comfortable blanket into a heavy, suffocating duvet, trapping way more heat than the system is used to handling. And that gets us to the fundamental problem. We are releasing carbon far faster than the Earth's natural systems, like forests and oceans, can reabsorb it. The planetary books just don't balance anymore. Tipping that carbon balance isn't just one isolated event. Oh no! It triggers a huge planetary chain reaction, a ripple effect that spreads across all of Earth's interconnected systems. It's really like watching a line of dominoes begin to fall. And the impacts, well, they aren't always straightforward. For a little while, more CO2 can actually act like a fertilizer for plants, making them grow faster. But pretty soon, the downsides, like intense heat and drought, start to overwhelm any of those benefits. And what's even worse is that as soils warm up, they begin to release their own stored carbon, which kicks off this dangerous feedback loop that just accelerates the whole process. The water cycle gets supercharged too. See, a warmer atmosphere can hold more moisture. Now, that doesn't mean it just gets a little rainier everywhere. It means the entire system becomes more extreme. So some places get slammed with more intense rainfall and flooding, while other regions are pushed into more severe and longer-lasting droughts. And yup, the dominoes just keep falling. As glaciers and ice sheets melt, sea levels rise. But there's another effect. That bright white ice is great at reflecting sunlight back into space. When it melts, it exposes the darker ocean or land underneath, which then absorbs more heat. That's a reduction in what scientists call albedo, and it creates yet another warming feedback loop. And at the same time, our oceans are absorbing huge amounts of this extra CO2, which is making them more acidic and really hurting marine life, like corals and shellfish. A line from the source material really just puts a fine point on it. The overall impact is a disruption of the natural balance between carbon stores and flows. It's not just one thing, it's the fundamental disruption of a planetary balance that's been stable for ages. So, after unlocking the vault and watching all these dominoes fall, where does that leave us? What is this new reality that the Great Acceleration has created for us? This is really the essential takeaway. We've cracked open a geological vault that took hundreds of millions of years to fill, and we're basically emptying its contents into the thin layer of our atmosphere in just a couple of centuries. The planet's systems, they simply can't keep up. Which brings us to our final and maybe most critical question. Our entire world runs on this ancient, buried sunlight, but now we understand the full cost of digging it all up. So knowing the true price of that energy, what do we do now?